Good morning, everyone. Happy Tuesday. I think it's Tuesday. Hope you're having a fantastic week so far. Jumping into another video in relations and functions, and this one is all about domain and range, which are ways for us to talk about what type of graph we actually have, or what type of data we actually have, or I guess what type of relation we actually have. So it's ways to describe certain aspects of them. So with that said, let's jump in and get to some domain and range. Alrighty, we're on page 423, looking at domain and range. Before we do, quick little review from last lesson. It says the x-intercept of a graph of a relation has a blank coordinate with a value of 0, and then the y-intercept of a graph has a blank coordinate with a value of 0. Well, an x-intercept, that happens when I'm right along the x-axis. I haven't gone up or down. My y-coordinate would be 0. Whereas the y-intercept, that happens on the y-axis. All I do is go straight up and down. My x-coordinate is 0. Okay, so that's a little review from yesterday. Okay, here is what we're actually doing today, domain and range. I'm going to read the definitions, and then I'll actually kind of talk about what that means and how we can find that. So the domain of a relation is the set of all possible values that can be used for the input of the independent variable. Or what that's saying is the domain is what x's can I have? What inputs are available within this relation? Okay? And then the opposite of that, the range would be, well, what outputs can I have? Okay, for the dependent variable, for the y, for the output, what are all the outputs that are available in this situation? Okay, and we are going to be learning how to kind of talk about domain and range based on every type of relation we know. We know words, we know table of values, ordered pairs, mapping, equation, and graph. Okay, so list the domain and range for the following set of ordered pairs. There's a little bit of notation that comes with it. So domain, I start with a D and then a colon, 2 dots. Okay. And then here's the hard part. When you're listing a set of numbers, like I'm listing my domain, I'm listing all of these numbers, what I have to do is called a brace or a curly bracket. And that's it's an okay curly brace. It's not perfect, but it does the job. Okay. And so what I'm saying for domain is for this set of ordered pairs, this is just a bunch of points. 1, 2, 0, 5, 3, 8, 5, 9, negative 3, 2. For all of those points, list all of the inputs. So you would say, well, 1 is an input, and 0 is an input, and 3 is an input, and 5 is an input, and negative 3 is an input, and that's it. So I end my list by closing the curly bracket, closing the brace on the other side. Okay? So if I ever have like just a bunch of ordered pairs and I'm asked for the domain, well, the domain just says, well, list all of your inputs. And the range says, okay, well, list all of the outputs. So I'd say 2 is an output, and 5, and 8, and 9, and 2. And I'm listing all of the y coordinates from those ordered pairs. Okay? And then there's another one. Well, let's do the same thing. Okay, so domain and range of all of these points, or all of these ordered pairs. D, colon. Open up your curly bracket. Okay, if your curly bracket looks like this, that's fine. Or that's fine. As long as it's not a normal bracket, I don't care. So open up a curly bracket. 3 would be an input. 0 would be an input. Negative 3 would be an input. 2 would be an input. And negative 8. Close my bracket. Range, you list all of the possible things you can get on the other side. I get an output of 3 from this point. I also get an output of 3 from this point. Well, I'm not going to write it again. I've already said 3 is one of my outputs. Well, and then I get 3 again. Well, I'm not going to write it. And then I'd write 9. Then I'm not going to write 3 again because I've already listed it. Your range includes 3. 3 is a possibility and 9 is a possibility. And there you go. So if I ever have just a bunch of points, I just list out the x values for my domain, list out the y values for my range. Okay. Now we're going to move to graphs. And this is where it gets a little bit trickier, but we'll be able to handle it. For the first one, okay, well, the first one is actually not maybe as hard as you might think. That's just a bunch of points, right? That's just a bunch of coordinate pairs, but they're plotted instead of written as the ordered pair. But if I kind of go left to right, I'd say that's an x value of -4, and then -3, and then -2, -1, 0, 1, 2, 3, 4. Close off that bracket. So just because it's on a graph, if it's just individual points, I can say what were the x values for those points for my domain. And then your range, that's saying, okay, tell me all the outputs. Tell me all the things I could get out of this, or tell me all the y values that exist. Well, that would be 0, 1, 2, 3, 4. Starting on the left, I have a y value of 0, 1, 2, 3, 4. And then if I work my way back down, 3, 2, 1, 0, I've already listed those. Well, there you go. There's your domain, and there is your range. Okay, let's go on to the next one. This is a little bit trickier. Okay, this is definitely going to be harder. And this is one where we want to practice a lot, and we really want to make sure we can talk about domain and range. So when I have a continuous relation or a line on my graph, okay, I have to be a little more precise. Okay, because if I tried to just list, if I said for domain, I can't say -5 and then -4, because if I zoom in on that section, there's also, -4.5 and -4.75 and -4.25, and there's every single point. I can keep going and going and going and getting closer and closer. The decimals would just get smaller and smaller and smaller. So I can't just list points. When it's a continuous line, I can't list points. So what I have to talk about is something to do with my variable. So this is where the notation gets a little bit more intense. And actually, the answer key in your workbook for some of the homework, they're lazy and they negate and they forget to put all this notation at the front, and they just put the very bare bones. But we do things better. We do things the proper way, so that if we ever marked on a written exam, we would know the right thing to do. So what I say, when I can't just list the points, I say, okay, well, the variable I'm talking about is x. And then I do a straight vertical line. And what that line means is such that. So far I have domain is x such that. Okay, and now I need a statement about x. I need to talk about x in some way. Well, what I notice is my x, okay, I have this -5 on one end, and I have this +5 on the other. And all of my x values are actually between -5 and 5. It's almost like I'm putting walls on either side of my domain. I have x values in the middle of that. Okay, so you can see everywhere in the middle, right? The line goes up and down. I'd have x values all the way in the middle of there, but I wouldn't have anything on the outside, so I can actually cap it off. Well, this is actually going back to something you did in 9th grade where you did systems of inequalities. And what I'm saying is if I'm going between these 2 points, the first thing I'm going to look at is x is everything to the right of -5. So x is greater than or equal to -5. And then from the other one, from 5, x is everything to the left of that. X is everything less than or equal to 5. And I'm at those points. There's a closed dots, just like it would be for an inequality. So I could actually equal those points. Well, that's actually my statement. I want to say x is greater than or equal to -5. X is less than or equal to 5. I want to say those two statements. And what we do, and I'm going to open up a new tab to say this, okay? This is a little bit tricky. This is definitely a new concept. Okay, so what I have is I'm saying x was greater than or equal to -5, but then it was less than or equal to 5. And what I have to do is combine those actually to one inequality. And the way we do that is by making the inequalities face the same way. So instead of saying x is greater than or equal to -5, I'm going to say -5 is less than or equal to x. And that's actually the same relation. X is still the big thing, -5 is still the small thing. And then this one's already facing the right way. And so what I have with these relations is actually one continuous statement. -5 is less than or equal to x, which is less than or equal to 5. So I write it as one inequality. There you go. That is the statement about my x, but it's really the two inequalities. It's really x is greater than or equal to -5. That's if I read it from the x towards that one. And x is less than or equal to 5. That's where I read the other direction. So it's from the x, you can read both statements. X is less than or equal to 5. X is greater than or equal to -5. Okay, so going back and actually putting that into a domain and range now, -5 less than or equal to x less than or equal to 5. That is the statement I put within my domain. I am saying x goes in between -5 and 5. Okay, which is all based on inequalities. And I built my walls. I talked about what the endpoints of those walls would be. And then I went from there. The last thing, I have to put a comma. And you have to say, well, what type of values in between -5 and 5? And this is where you say x element, which is like a C, but with a line through the middle to make it an E. It's like a curved E. Of the reals, so the real number system, anything, any decimal, any fraction, whatever, any real number between -5 and 5. So that would be an R, and the R is supposed to have two vertical lines. And now I'm done, and I close off my brace. Wow, that's pretty tedious, right? That's pretty intense. So the more we can practice these domain and range, the easier it's going to become. And really, what you're going to notice is this statement, the only original piece of this statement is the -5 and 5. Every other time you do this, it's the exact same as this, okay? But it's just finding what's my side and what's my side, okay? Really, that's all it comes down to. Okay, let's do range now for this one. So I'd say range, open up my curly bracket, and it's going to be y such that. And what I noticed for my y's is, okay, well, I put like walls, or I put like side for my domain. For range, I'm putting like a roof and a floor. And what I notice is all my y values are below 4. They're all down this direction. And none of them cross the x-axis. They all stop at 0. Okay? They're all in the middle of 0. So my domain is between -5 and 5. My range is between 4 and 0. So what I'd say is you always start with a smaller number. Y is greater than or equal to 0. And then at the same time, y is less than or equal to 4. And then I blend those together. 0 less than or equal to y less than or equal to 4. That is my statement. Or really what that's saying is y is between 0 and 4. And it can also equal them. 4, y is an element of the real. All right, there you go. That's domain and range for a hefty question. Okay, a little bit tough. So with domain and range, takes a lot of practice, takes a lot of getting used to. So we'll really do a lot of homework today to make sure we get this down. Okay. Number C. This one's a little different, and it's actually easier. So the first thing I notice is these arrows, where these lines are going to go on and on forever. So in terms of my domain, I'm kind of thinking, well, along the x-axis, when does this stop? When do I stop having an x value? Well, the thing is, an arrow means that's going to continue and continue and continue in both directions. So in terms of my whole goal is to put up the walls to say, okay, at this point, all of my x values are in the middle. I can't do that. Because it's a diagonal arrow, it's going to go down and over and over and over and over and over and over as far as you can see. So all I can say, domain is such that, x such that, okay, well, I can't say anything. It goes all the way to negative infinity, goes all the way to positive infinity. It's just every possible number. And the way I say every possible number is x is an element of the real. And that's all I have to say. Okay, which is great, which is really, really great. So if I have no borders, I can't stop this thing at all, I say x element of the real. Okay, if I have a border on either side, I can do what I did in the last question, okay, and contain it from here to here, from here to here. Okay, the third thing is, so now we're doing range, y such that. Well, the range, now I'm looking at the y's and I'm looking at a roof and a floor. I have a roof, okay? From a value of 4, everything would have to be down. Y is less than or equal to 4. But then in terms of putting a floor on that, I have a roof. In terms of putting a floor, this arrow, I'm going over and down and down and down and down and over and down and down and down. Those are going to continue downwards forever. I'm never going to be able to put a floor on that. So I actually don't have a bottom. Really, I have the one statement is 4 is the top, but then it could be anything less than that. So y is less than or equal to 4 for y is an element of the reals. And that's the whole statement. Okay, I don't have to put both ends on it because it only has the one end. And I'm good to go. Okay, so those 3 examples encompass everything we have to do with domain and range. Okay, they have, hey, if I just have ordered pairs, if I just have dots, list the x values, list the y values. Okay, well, if I have a contained system, I have to say x goes from here to here, from -5 to 5. And y goes from here to here, from 0 to 4. And then if I have an uncontained system where I can't put my sides, I can't put my roof or my floor, maybe it's just x element of the real, or over here would have just been y element of the real. Or in actuality, I do have a restriction on y just on one side. Okay, so that's domain and range. I'll post another video explaining domain and range for you to watch if you want. But for now, let's move on. Okay, it says state the domain and range of the following relations. This is where I'd actually challenge you to pause the video and try all 4 of these ahead of me. And then I'll jump in and do them.
1 hour later.
Okay, so hopefully you tried these domain and range ahead of me. I'm going to go through and tackle them all one by one, and hopefully we're able to get the same answer. So first one, it's like a U. It's got arrows that I noticed going up and up and up. And I noticed the connected line. So for domain, I'm going to start the curly bracket x such that, right? It's not just points. I can't just list points. I have to talk about using inequalities and then expressing a certain kind of region, okay? Well, in terms of arrows, these arrows are going up and slightly over, and they're going to keep going slightly over forever. Any sort of diagonal, any sort of angle is going to go over and over and over forever. It's just going to keep going and going and going. And if I had more screen, we'd go further and further and further. So as long as there's an arrow slightly angled in both directions, x element of the real. That's all I have. Okay. In terms of range, well, range was all about, can I put a roof and a floor? I can't put a roof. My arrows are going up and up. I'm never going to be able to top the roof, but I can actually put a floor on this one. I'd say all of your y values are above. They're greater than or equal to -3. And that's what I can put. Just the one restriction. It's not between this and this. It's just y is greater than or equal to -3. There you go. Okay. Let's go on to the next one. This is an oval of sorts. Okay. Domain x such that. It's the connected line, so I'm going to definitely have some restriction. And this one's great because domain, that's your x's. You're trying to put walls up. Yeah, I've got a wall right here. That is saying everything this way. All my x's are contained by that wall. And then over here, I've got another wall, which looks like I go, so -2, it looks like. X is greater than or equal to -2. And x is less than or equal to 4. So those are my two inequalities. If I blend them together, it's always small, less than or equal to x, less than or equal to the big one. -2, less than or equal to x, less than or equal to 4 for x element of the real. And that's something the more we practice, the more the habit we get in, the easier that's going to become. Okay, range on this one is very similar. Start it off, range y such that, put a floor, put a roof. Looks like my roof is right about here. That's at like 1, let's call it. Y is less than or equal to 1. Everything is below that. And then what would this one be? 1, 2, let's call that 3. Y is everything bigger than -3. Same idea. It's going to be less than or equal to y, less than or equal to for y element of the real. And what I have to look at is, what is the smaller number? What is the bigger number? Well, a negative would be smaller. So -3 is less than or equal to y, is less than or equal to 1. And there you have it. That's my domain and range. When I'm locked in, I've got both sides of my walls and I've got a top bottom. I've got my floor and roof. Okay. Arrow diagram. This is the easiest one. Okay. Because all of my inputs, that makes up the domain. So 1, 2, 3. Those are my inputs. I just list them. And range, 2 and 6. Well, those are my outputs. So I just list them. That's it. If I have ordered pairs or an arrow diagram or just points on a graph, just list the x values, list the y values. List the inputs, list the outputs. It's the easiest thing. Okay, easiest thing. D, a circle with a center of -2, 3 and a radius of 3. All right, well, if I'm going to do this one, I'm going to draw a picture. So it'll be a crude picture, but it'll be good enough. -2, 3. Back 2, up 3. There's my center. And it says a radius of 3. So what I'm going to do is I'm going to kind of make the 4 points around, above, below, to the left, and to the right of where this circle would be. Okay, if it had a radius of 3, well, down it would be 1, 2, 3. Oh, it actually goes to the origin. Okay, if I went upwards, I need my ticks. That would be all the way up to 6. To the left, I go 1, 2. I would just have to go 1 past the y-axis. And going backwards, I need to go 3 ticks to the left. So my circle, really poorly drawn circle, but that's okay, would kind of connect with all 4 of those points. Okay. And then from there, it's pretty easy for me to state my domain and range. My domain, D such that, X such that. Well, it looks like I go all the way from -5 to 1. -5, less than or equal to X, less than or equal to 1. Once I get this pattern down, I can really fly through domain. The smaller number to the big one, my inequalities face the same way. In terms of range, y such that I go from 0 to 6. 0 less than or equal to y, less than or equal to 6. I'm saying, what does it go in between? My inequalities would face the same way for y's element of the real. There you go, domain and range. So you're going to do lots of those for the homework. Make sure you ask lots of questions about it. Domain and range is a really good way to classify information and talk about a relation in a function. And then it's going to come back at the 20 and 30 level as a more important way to distinguish things about a function and tell us things about a function. And it's a very useful thing that we need to have in our back pocket moving forward. Okay, let's move on. This is at the bottom of that page, I think. It says, draw the graph of a relation which has domain X element of the real. Okay, and the range is Y is less than or equal to 2. So this is just maybe kind of thinking about domain and range and seeing if we can be creative. So my function has to have a domain of XER. So it's going left and right the whole way, but it has to be less than or equal to 2 in terms of range. So, all right, here's a little graph. And what I'm going to label is that Y value of 2. I'm just going to put a dotted line kind of considering it. So my entire graph has to be below there. Same thing for the other one. Okay. And it's challenging you. It's saying, can you draw a graph that has only one x-intercept? And then could you draw one that has two x-intercepts? Okay, so here would actually be a good opportunity to pause the video, seeing you can do it ahead of me.
A little longer than a few minutes later.
And we're back. And I'll do these ones, right? It's maybe interesting to consider on your own. I'll see if I can do it. So only one x-intercept, but the x's have to go on and on forever. Okay, well, what I'm going to do is it's going to come up from the left, crosses the x-intercept. That's my one x-intercept. And then it's just going to make a sharp turn. There you go. Right at y is equal to 2. Okay, that's fine. That totally works. I don't know what the equation of that thing would be. It would be two equations, actually. But it works. Okay, it meets both criteria. Two x-intercepts, I think, is actually easier because I can go from that point down one way, down the other, throw some arrows on it. It's going side forever. There's my two x-intercepts. Okay. Let's see this one. It says, explain why it is not possible to draw a graph which has domain XER with the range of y is less than or equal to -2, but has no x-intercepts. Okay. Well, the reason for that would be, if I draw another graph like this again, okay, the fact that it says y is less than or equal to 2 and y is an element of the real, if I start at a y value of 2 and I'm going to go down forever for every real value, the only way I can do that is by going through the x-axis. So yeah, it makes sense. If y starts above the x-axis and never stops, of course you're going to cross the x-axis. Okay, and that's it. Okay, we're going to skip number 5. That's just a graphing question, not really related to domain and range. We're going to go to some homework. Okay, 1 odd 2 4 8. Really important, and I will post a video of someone else explaining domain and range that hopefully helps out. So there you go. And that's another one in the books for us. So that's domain and range. I would say this is a bit more of a confusing topic. It's a little bit new. It's blending that inequalities from grade 9. So watch the extra video that I'm posting and reach out. Send a question in the Google form, book a one-on-one meeting to make sure we understand what we're doing with domain and range, and make sure you do the practice. Okay. As always, smash the like button, smack the like button, smash the like button, hit subscribe, all of that. Tune in again tomorrow for another video.